Good morning, ma'am.
Good morning, Miriam. How are you?
Fine, ma'am. Ma'am, how are you?
Fine, thank you. Hello, Rasha.
Hello, ma'am.
Hello, Halima. Halima doesn't seem to have a mic. Hello, Halima.
Hello, ma'am.
Hello.
How are you, ma'am?
I'm fine. How are you?
I'm fine, ma'am.
Good. Hello, Aruba.
Hello, ma'am. Assalamualaikum.
Okay. So let's start. Okay, let's start with a small recap. What were we studying last time? Yes.
मैम हमने लास्ट में एक फार्मूला पढ़ा था E is equals to mc square.
Okay, we have yes, we have been studying this for the last several classes. In fact, this is in the beginning of the chapter. We've already studied this several times, and last time we applied this formula to solve some problems, to do some calculations and see how it works, right? Okay, yes, Sahib. Sahib, what would you like to say? Anyone else who would like to say something? Okay, so today we are going to continue solving problems using the concepts studied in this chapter. We've already studied this chapter throughout the previous weeks, and now we are solving problems related to the concepts that we have been studying, right? Okay, so let's see. I'm going to share the book. Yeah, we have it here. Okay. I gave you a problem as a homework also. Did you solve it? Do you remember the problem I gave you? So we talked about this problem, we started it and I explained it to you and I told you to solve it as a homework. So if any of you can help us solve it, then I'll give you a point for solving it, okay? This was the problem that we discussed last time and I gave you this, I explained the problem and asked you to complete the solution at home, and if anyone would like to explain this, I would give you a point for this. Okay, so think about it. I'm going to take your attendance. and then you can tell me your name, and then you can solve it, and I'll give you a point for that. So Ahmad Hassan, Fahad bin Ahmar, Aisha Hafiza, Ali Musa, Mahnoor Amjad, Nimra Arif. Okay. So Farooq Ahmed, Azad Asad, Khawar Gill, Laiba Khalid, Sahib Khan, Elia Shafqat,
Yes, ma'am.
Amna Maham,
Present, ma'am.
Tashra Rashid,
Present, ma'am.
Aruba Riaz,
Present, ma'am.
Nawab Siddiq, Tahir Sumawi, and Saura Pakistan.
Ma'am, have you name? You did mention the name.
Whose name?
My child.
Harima, I called your name.
Halima, I just.
Yes, I called your name.
Sorry, then I didn't hear it. Ma'am, please mark my attendance.
Okay. Okay, so now we continue with the problem. Yes, who would like to explain this? Yes. It is already solved there. You just need to understand it and explain it. That's all you're doing here. Okay. Okay. So the concepts here, this is the problem statement. Uranium, we know, is radioactive. It is represented by U. And there are many isotopes of uranium. We are talking about U-238. It means that the atomic mass is 238, right? So this means that the number of nucleons, neutrons per protons is 238. Is that clear? Okay, so U-238, we know is a radioactive element, and therefore radioactive elements have this property that they decay. So this is the process, this is an example of a fission reaction. So the concepts here, we talked about nuclear reaction, and the fission reaction is a type of nuclear reaction, right? So this is fission. Fission means the breaking up of a nucleus such that new nuclei are produced. These are called product nuclei, plus the emission of neutrons and radiations like gamma. So in this process, there's a difference in mass, and that mass is known as mass defect in AMU or U, okay, which is then converted into energy using E is equal to mc squared, the same concepts that we've been discussing. So we have to first determine the mass defect, then we multiply it by c squared, and then we convert it to energy. This is what the problem is about. So in the statement, they've given us a lot of information. They've told us that U-238 will change to, will go through the fission reaction, and it will change
Excuse me,
yes,
I have a question.
yes.
Uh, जो एटॉमिक बम्स वगैरह होते हैं उसमें यही एटम्स यूज होते हैं, यही एलिमेंट्स.
They are based on the principles of fission and fusion. They're based on the principles of nuclear reaction. Okay, but that's not the topic of our discussion, and we will not go into the details. But yes, the basic principles are the principles of fission and fusion. They can be used to do that. And nuclear reactions, yes, this is also a concept, and the concept of conversion of mass of energy. These are the same concepts. But we are speaking from the point of view of nuclear power, which is the production of electrical energy using nuclear. And as you know that Pakistan has nuclear power, it has nuclear reactors. We are generating energy, and new reactors are being built. Recently, there was a new reactor that has come up. So we are talking about the positive applications of science and of nuclear science, right? So of these applications, we are talking about fission and fusion in the context of nuclear energy or nuclear power. Is that clear? Okay. And also we can relate, we can relate these concepts to, for example, the fusion processes that are taking place in the sun, for example, and in several other stars. You know, it's a source of huge energy. So fusion is something that's up till now is under a research stage. It's not yet commercialized. So if we are successful in building the prototypes, then we will have a huge source of energy. Meanwhile, fission already has been developed, and we've been using fission energy for the last several decades, and we have had several generations of reactors. Okay, so we are talking in that context. Okay, so in this case, this is the reaction, and I'm not writing the complete reaction because you do have, in addition to this, you have neutrons and gamma radiation that will be emitted. But we are only keeping to the statement of the question and what we've been asked to do. Okay. So we are just talking about a nucleus, which is U-238, which is a radioactive nucleus, and then it undergoes the fission reaction, and as a result, you have these product nuclei, which are lead and helium. So there are 8 helium atoms. So maybe I should write this, because you know the equation has to be balanced on both sides. So these are 8 helium atoms. So plus 8 helium atoms. These are actually nuclei. When we're talking about nuclear physics, we talk about the central part of the atom, which is known as the nucleus, because it's the nuclei that take part in these reactions and not the electrons, right? So what happens now? We want to know the energy change in this process. We know that there's a mass defect, and the mass defect, this is here. Mass defect is the loss in mass, and this is 0.0555 in U. Can anyone explain how we got this? Can you explain how we got this mass defect? I would like you to use your calculator and put these values that are given over here and tell me the values on both sides. Can you do that? Okay, do it. I give you 1 minute and then you tell me the answer and I give you a point for this. Okay? Okay?
Yes, ma'am.
Yes, ma'am.
Please do it. Use all the decimal places, because you know in this equation, even if there's a very small fractional mass, when it's converted into energy, it becomes a huge amount of energy, as I've explained previously, right? So use all the decimal places.
Ma'am, I got ma'am.
Amna, please explain it.
मैम जो ये दिया हुआ है 8 को पहले हमने मल्टीप्लाई किया 4.00260 के साथ,
अच्छा, so you are
तो उसका आंसर आया था 32.020824.
0.00280.
यस मैम। इसको मल्टीप्लाई किया तो ये वैल्यू दी हुई है 2.5 सॉरी 205.9449, यानी कि जो पीवी की वैल्यू दी है उससे प्लस किया।
तो 5.974449, ओके।
जब इसको सॉल्व किया तो हमारे पास
हाँ, we
मैम
have
जब इसको सॉल्व किया तो हमारे पास वैल्यू आई थी
आवाज,
2.99%।
the value was 237 point 99527 point 995273. Okay, and on the other side we have
मैम जो यूरेनियम मैथ्स लूज वो आया।
आपकी आवाज बहुत कट रही है।
मैम अब आ रही है 1 मिनट,
बोलो।
1 मिनट मैम। मैम अब आवाज आ रही है आपको मेरी?
यस आमना, आमना भी आ रही थी आवाज।
जी मैम। मैम हमने ये किया था कि जो ये एच ई की वैल्यू दी थी उसे 8 से मल्टीप्लाई किया, उसके बाद जो भी जो उसका आंसर आया था उसको हमने ऐड किया था 205.974449 में।
ठीक है,
तो उसका आंसर आया था ये आया था 237.995273, जिसको माइनस किया हमने यूरेनियम 238 के जो वैल्यू दी हुई है
yes,
0.050784, तो उसको जब दोनों को माइनस किया तो फिर ये आंसर आया 0.05551।
very good. Okay. So we will very good, Amna. I've given you a point. Now I can explain this again over here on the board. So we have the given reaction is uranium 238 undergoes a nuclear reaction of fission, and it splits into two product nuclei. One is lead, right? And this is 206 plus the other is 8 atoms of nuclei of helium 4. Now we have to see the masses on both sides. So the mass for uranium is given as 238 point.
ये का पता है तो तब मैं पूछता हूँ। Right, ma'am. I have a question.
Yes, Sahib.
मैम मैंने पूछना ये था कि जो E इज इक्वल टू MC स्क्वायर का फार्मूला है, सो ये हाइड्रोजन बम में भी यूज होता है, क्योंकि पिछले एक जुमे के खुतबे में एक मौलवी ने कहा कि अगर हाइड्रोजन बम बनानी हो तो ये फार्मूला यूज करे, लाइक इसराइल के हवाले से वो बात कर रहा था।
We are not discussing religion or politics, please. ठीक है, I don't want to discuss this. ठीक है,
लाइक फ्यूजन और फ्यूजन में मुझे
no, we don't want to talk about this, right? This is not a
Like-
topic of our class, right? We have nothing to
like just I want to know the difference between fission and fusion reaction.
वो मैं आपको बता देती हूँ, बल्कि वो मैंने आपको वीडियो भी एक अपलोड करके दी, आपने वो वीडियो देखी? मैंने फिशन और फ्यूजन दोनों में की है और मैंने एक्सप्लेन भी किया था प्रीवियस क्लासेस में. We'll just discuss it. Let us finish this problem, okay?
Right, वो implode और explode वाला में
एक जो है उसमें न्यूक्लियस ब्रेक करता है और एक जो है उसमें दो न्यूक्लियाई फ्यूज करते हैं. तो fission is the breaking of one nucleus, okay, and fusion is the fusing together of two nuclei. समझ आ गई है ना?
राइट.
हाँ, और इसकी आपने ज्यादा डिटेल देखनी वो वीडियो में आप देख सकते हैं, राइट? 0.0507 okay, and for lead we are value of 20. Acha, when you have problems related to this, since this is an example, the values have been given, but it's not always necessary for these values to be given. If these values are not given, then you can check them up from any source. Okay. So anyway, in this case, the values are given. So we are using these values. You can check them up these values are given. You can find them in books. You can find them in tables in the internet, and you can find these values of the masses. But remember the units. The units should be in U in this case. So 205 point. Amna, bolo zara ye kya hai? 205 point.
205.97 449
Plus 8 multiplied by 4.00 2603. Okay, so now when you first you multiply this, and you add it to this, and the value you will get here is as Amna has just calculated 237 point.
मैम जब 8 को मल्टीप्लाई किया था तो 4 वाली वैल्यू में से तो इसका आंसर आता 32.020824 32.020824.
And on the other side we have the same value 238.050784. Now when you take the difference of these two values, when you subtract this value from this value, this difference is known as mass defect. Okay, this difference is called mass defect, and when you do this 238.050784 minus 237.995273, then this value comes out equal to be 0.055555511 U. Okay, so this is how we got this value. So now what can you see at the moment? आपको क्या नजर आ रहा है?
मैम बुक
नजर आ रही है. अच्छा,
यस मैम.
ठीक है, तो आपको अब ये समझ आ गई है कि ये वैल्यू कैसे निकली है.
यस मैम.
ये वाली वैल्यू मैंने अभी निकाली, ये वाली. ठीक है.
यस मैम.
तो नाउ यू अंडरस्टैंड हाउ वी गॉट दिस. ठीक है, इसको ज्यादा मैंने डिटेल में लिखा है ऑन द बोर्ड, सो आई कैन शो यू ऑन द बोर्ड आल्सो. सो नाउ यू कैन सी दिस ऑन द बोर्ड. समझ आ रही है यहाँ से? You can see the board, right? So this mass defect, now when we apply, now you can see the board, है ना? When we multiply
Yes ma'am.
this mass defect with C squared, then we will get the energy. So the energy will be 0.055511 U multiplied by, okay, so we don't have to do this. Actually, we can use the value that we had in the last class. In the last class, we calculated that 1 AMU. In the last class, you remember, one page before this page, you remember that we proved that 1 U is equal to what? How much energy is 1 U equal to? So you can do it by the long method where you perform the calculation we did last time again, or you can use the short method in which you use the value that you obtained from the last problem that we did last time, which was 1 U is equal to 931.5 or 0.49 MeV. So last time we calculated this, and we can use the value straight away, or if you don't remember that value, then you can calculate it again. So 1 U was equal to 931.49 MeV. So we can take this mass 0.055511 multiply by 931.49 MeV. So this will be equal to, this will come out to be equal to 51.71 MeV. This is the energy state. 51.71 MeV. And remember that M means 10 raised to 6. So this is 51.71 into 10 raised to 6 electron volts, amount of energy. Okay, so this is how we have converted this. So is it clear now?
Yes, ma'am.
Okay, so I share the book again and you can see how we have obtained this value. I've explained in detail how we got the value of this 0.05511U, and I've also explained how we got 51.71 MeV. So this energy change can be converted into MeV or joules according to the question, whatever question you have. If they ask you to do it in MeV, you do it in MeV. If they ask you to do it in joules, you know both methods because we also discussed them last time, right? You know the equivalence between electron volt and joules and so on, right? And here again it has been explained. And remember that this is equal to gigajoules. Giga is a large amount of energy. You know that, right? Giga means what is giga?
मैम 10 की पावर 9
10 to power 9. So mega is 10 raised to 6 and this is 10 raised to 9. So you see it's a huge amount of energy. So according to the problem that has been given to you, you're just going to put in the values and you're going to find the energy, the mass effect, and then the energy. And then you have to look whether you have to do it in MeV or you have to do it in joules. So according to whatever you are being asked, you could do it. Yes, Nimra, I have marked your attendance. Okay, so Nimra Khan. So this is an interesting problem and the same method can be used in order to solve this problem. You see, in this problem, we have a very similar question, which is again a uranium isotope. So you know that elements can have more than one isotope. So the one that we discussed in the above problem was U-238. In this case, it's again uranium, but it's U-235. Okay. So this is used as a fuel in reactors of nuclear fission power stations. So if the reaction occurring is U-235 plus a neutron is giving you barium-139 plus krypton-95 plus 2 neutrons. So what is the loss in mass per atom of uranium fissioning and what is the energy equivalent in gigajoules per mole? So use the mass of the atoms in the table below and you can solve this. So I think this is very easy. You just have to substitute this value of mass here plus this value of mass here, and in this case they also want you to include the mass of the neutron to get a more accurate reading. So we multiply 2 by this mass of the neutron. So this will be the masses on the right hand side and you take the total, and then the mass on the left hand side is this, and then you take the difference between these masses. This will be the mass defect. You multiply this, okay, with the value that we just did according to the equation E is equal to mc squared, and you will get the energy produced. So in the first case, the question is not about energy. The first question is about the loss in mass. The loss in mass means the mass defect. So please understand the question also. Don't directly write your answer. First understand the question. What are they asking? So in the first part, they're not asking about the energy. They're asking about the mass defect. So the mass defect is just what I explained to you, the difference in mass. And the second part is about the energy. And now they want you to calculate the energy in gigajoules per mole. So you can either do it by this method in which you can first calculate it in MeV and then convert it to gigajoules per mole according to the method that we just discussed. Is that clear? Okay?
Yes, ma'am.
Very good. Okay, so now we're going, again, we are now practicing this chapter. Actually, we have completed this chapter before, but we're just practicing it now. So a topic I would like to practice today is about the stars, right? Okay? Here, this is the topic. So what is a star? What is a star? Let's start with a very simple definition of a star. Yes, who would like to answer this?
Ma'am, stars are bodies that have very large bodies that has their own light.
Right, so I'm now going to share the board with you, okay? A star is an astronomical, what can you see right now? You can see the book, right? Okay, a star is an astronomical object consisting of plasma held together by its own gravity. ठीक है? सही है? What can you see right now?
Yes, ma'am. Yes, ma'am.
क्या नजर आ रहा है आपको?
Book, ma'am.
Okay, so yeah. So we can write the definition of a star. A star is an astronomical object which consists of plasma held together by its own gravity. So what is plasma? What is plasma? Yes, what is plasma?
Plasma is matter.
Yes, plasma is a form of matter. So can you explain it a little bit?
Right, so this is the fourth form of matter, right? It is
It is the
either gas.
fourth state of matter, right?
Yes.
Yeah. And what does it look like? What is it composed of? Who would like to add to this? It is one of the four states of matter. So you have states of matter like solid, liquid, gas, and so on, right? And in this case, it is composed of a gas of charged particles. Okay? ठीक है? It consists of a gas of charged particles like ions, atoms, molecules, which have one or more orbital electrons stripped. So they become ions, and it's a combination of these charged particles of ions and free electrons and so on. And therefore, this is plasma, and it has a high temperature. Okay? Because at a high temperature, an electron or an atom or a molecule loses its electrons. Okay, na? Sorry, an atom or a molecule loses its electrons and thereby becomes charged, and then you will also have free electrons, and this combination, this gas of ions and free electrons is known as plasma. Okay? So we can put the definition here. Okay, right. So when we talk about stars, we talk about the relationship between um, temperature of a body and the wavelength of radiation emitted from that body. So this shows that there's a relationship between the temperature and wavelength. So you remember that we have talked about wavelength in chapter number, which chapter did we talk about this? Chapter 2 or 3? So the temperature and the
Both.
wavelength. Fourth में तो velocity थी.
लेकिन मैम इसमें वेवलेंथ दोनों में आते हैं ना, मतलब चैप्टर 2 में भी वेवलेंथ रहती है और चैप्टर 3 में
Anyway,
वेवलेंथ है.
you're familiar with the concept, right? And temperature is also related to this, and you can read the detail here, right? And then you can identify the surface temperature of a star and its color. So color is also related to temperature. Again, this is also explained over here. So we have laws in physics that can explain how temperature is related to color and then to wavelength. And this concept is explained by a diagram which is known as the Hertzsprung-Russell diagram. It's known as the HR diagram. Again, in this under this heading, you have this explanation here as well. I will also give you the link to a video in which this is explained. Okay, these concepts are also explained in that. So yes, someone here is writing, Sahib Khan is writing, bodies that emit heat and energy matter. Okay. And right, okay. Okay, so and then identify energy sources, characteristics of each star group, including the main sequence, the red giants, and the white dwarfs. These are types of stars or groups of stars. Okay, so these are the terminologies under this heading. Now we know that how do we study stars? We study stars by observations and measurements. We know we talked about galaxy. We talked about the fact that there are many galaxies and we are also a part of a galaxy, and each galaxy contains billions of stars, right? So each star is a huge system that can be studied by measuring different properties like temperature, pressure, volume, and these can be then be related to various concepts, and we can understand a lot of details from these observations, right? So we can observe and measure the electromagnetic radiation that comes from these stars. Electromagnetic spectrum, I showed you a spectrum which is coming from the sun, for example. It consists of various different wavelengths, and corresponding to each wavelength there is a certain energy and a certain frequency and a certain wavelengths. They go together, right? You can convert from one to the other, and then you can you can study this spectrum. This study of the spectrum is known as spectroscopy, and you can try to understand these properties of the stars and how they are named and how they're classified. So the things that we study about stars are the position, the mass, the composition, their magnetic fields, motion, temperature, power. Of course, there are sources of power. Like the sun, we said, produces a lot of power through the process of fusion. So the sun is also a star, right? So this is, please study this in detail, and we all have a small formula here. With the help of this formula, you can study the intensity of the radiation that is being emitted. And then you can relate this intensity of radiation to luminosity. Luminosity is a term that's associated with the power output, okay? So you can calculate these values, and then you can understand the various concepts that we just mentioned. So in this case, intensity and magnitude, for example, these are small formulas given here. Again, these are about the intensity of this radiation that is emitted, or it is the power which is, it is defined as the power received over each square meter. Okay. So you can study this. Again, you can, I'm also going to give you links to two videos today, and you can relate these concepts to those as well. So you can see them visually, plus here in the book you can read the concepts and also use the small formulas that help you make these calculations. So this is again a law for the intensity in terms of the distance. Okay. So the meeting is going to end, and now as your homework, please practice the concepts we've talked about, practice the problems we've done, and solve similar problems and prepare yourself accordingly. Okay?
मैम प्लीज
Yes, ma'am.
Yes, ma'am.
कौन बोल रहा है इसमें? साहिब आपकी होगी अटेंडेंस.
थैंक यू सो मच.
Okay, take care.
Okay, ma'am.
Allah Hafiz, ma'am.
Hafiz.